Okay, hi students, welcome again to our YouTube channel. So we are going to proceed over previous video. Last time we did 5 questions of the paper 2020 GCSE AQA. Today we are going to discuss the next question, that is question number 6. Now we are going to start. This question is about displacement reaction. The displacement reaction between aluminum and iron oxide has a high activation energy. So what is meant by activation energy? So first of all, as we know that the activation energy is the minimum energy required or needed to start the reaction or for reaction occur. To start reaction. Okay. Now here the question is, a mixture contain 1.0 kilograms of aluminum and 3.0 kg of iron oxide. So the equation for the reaction is 2 moles of aluminum react with 1 mole of iron oxide. Okay, shows that the aluminum is limiting reactant. So for the limiting reactant, you have to remember that first you need to find the moles of each reactant. Okay, and then you can compare the molar ratios. Okay, first of all, here are the aluminum that the mass is 1.0 grams, so you have to convert it into that is present in kilograms, so you have to convert into grams, so that is 1000 gram, while the iron oxide, that is 3000, because here is 3 kg, it means there will be 3000 grams. Okay, now you have to, as you know that the moles equal to N1 is equal to mole divided by the molar mass. So aluminum is 27, so you have to divide here by 27, while here the iron oxide, that will be N2, you can say, like the moles, that equal to 3000 gram divided by the molar mass, so that the molar mass will equal to here 2 times 56 plus 3 times 48, so that equal to 160. Alright, so you have to divide here 160. So when you divide it, N1 is equal to like 18.75 moles, while N2 will equal to, that is, when you divide here, let me calculate again, 1000 divided by 127, that equal to 37.0 moles. Okay, while 3000 divided by 160, that will equal to 18.75 moles. Okay, now if you see in the reaction, there are the 2 moles of aluminum and 1 mole of iron oxide. So it means here that moles are actually the 2 moles of the 2 moles of aluminum, while these moles are the 1 mole of iron oxide. So you have to equalize them. How? By dividing the aluminum moles, because here are the 2, so you have to divide by the number 2, because that is that is present in the equation. So you can see here 2 moles of aluminum react with 1 mole of iron oxide. So when you divide it N1, so N1 is equal to like 37.0 divided by 2, so you got 18.5. Alright, so here you can see that 18.5 is the smaller value or less value as compared to 18.75. So that's why aluminum is the limiting reactant. Alright. Okay, next question. Magnesium displaces zinc from the zinc sulfate solution. Complete the ionic equation for the reaction. Okay, you should include the state symbol. So here magnesium is solid, zinc is in ionic form. So after the in the product there will be, like, magnesium will be here Mg, because you can see that is solid and there will be in ionic form because magnesium loses 2 electrons, while the sodium will gain 2 electron and it will form sodium solid. So you can write in this state. Okay. Not sodium, here is zinc. Sorry. Okay. Now the next question, 6.4. Explain why the reaction between magnesium atoms and zinc ions is both oxidation reduction reaction. Please remember that the oxidation reduction reaction means that is redox. It means that is the redox reaction. Why? Because here the magnesium are oxidized. Oxidized mean loss of electron. Okay, because here the electron lose, while the zinc will be reduced. Zinc is reduced because electron gain. Alright. Okay. Now question number 7. The reaction between hydrogen and oxygen release energy. Okay. A student drew a reaction profile for the reaction between hydrogen and oxygen. Okay, the question is, the student made 2 errors when drawing the reaction profile. Describe the 2 errors. First, if you see that there is the release of the energy, it means it should be, the reaction profile should be for exothermic. And in exothermic, the reactants are at higher state and products are at lower state. Okay, but if you see that reaction profile is actually for endothermic. Okay, so you can write here the first error, that the student drew endothermic profile. Okay, and the second one, that is the activation energy in the profile, that would be wrong, because here the activation energy should be from the reactants line to the peak. Okay, from the reactants line to the peak. So you can write here the activation energy like the activation energy should be from the reactants. Alright. Okay, next. The reaction between hydrogen oxide and the hydrogen fuel cell is used to produce electricity. Give two advantages of using fuel cell or hydrogen fuel cell instead of using rechargeable cell to power the car. So we already discussed the in detail like that question in the previous video, like that is also regarding to the GCSE paper, in which we also discussed like the table in which we compare the hydrogen fuel cell and the rechargeable cell, like the properties. Okay, so now here the first one advantage of using the hydrogen fuel cell instead of using rechargeable cell, that is because the hydrogen fuel cell is non-toxic chemical to dispose, non-toxic chemical to dispose at the end of the cell life. Okay, and the second one, that it take less time to refuel, take less time to refuel. Okay, next, reaction occur at the positive electrode and at the negative electrode in the hydrogen fuel cell. So write the half equation of for one of these reactions. So you have to write any one. Okay, so like for example, I am going to write here one of the example, that is like the H2 hydrogen gas that will release the electrons, two electron, and it will convert it into two hydrogen ions. Okay, now the next one. The three states of the matter can be represented by a simple particle model, showing the simple particle model regarding for the hydrogen gas. Give two limitation of this simple particle model for the hydrogen gas. So the first limitation, as you know that like the hydrogen should be in diatomic form, and that should be these two dots that should be attached with each other, because H2 not present in a single atom, it should be present in H2 form, hydrogen gas. Okay, so that should be in diatomic form. So it means that here is, you can say that hydrogen is not shown as H2 molecule, or you can say hydrogen is not shown as molecule. Okay, because of the single atom representation. Okay, and the second one you can write, like for example, if there the hydrogen is already not shown as like a molecule, so you can write like a different limitations, like the particles are shown as a sphere. Okay, and particles are shown as a solid, and does not shows, there will be no like you can say the forces that are present, so it means does not show the weak forces between the particle. Okay, and does not show the movement or speed of the particle. So you can write any one, like for example I am going to write the second one, that is the like that does not show any force, does not show any weak force between the particles, weak force between them. Okay, now next question. The hydrogen gas needed to power a car for 400 km would occupy a large volume. Suggest one way that this volume can be reduced. For the reduction of the volume, pressure should be high. Like when under high pressure, what will happen? The volume condense, because you can see that it allow the increase the concentration and allow the condense. Okay, due to condense, what happened, like the hydrogen gas that will be stored as a liquid form, H2 stored as a liquid or solid. Okay, so allow develop more efficient engine. Okay, next question is 7.6. That is energy needed for a car powered by a hydrogen fuel cell travel to 100 kilometer. So energy needed, that is 58 megajoule. So 58, you have to convert 58 megajoule into kilojoule. So that would be 58,000 kilojoule. That is energy needed. Okay, like let's suppose I am going to write en just as indication, there will be energy needed. Okay, now energy released when 1 mole of hydrogen gas react with oxygen is 290 kilojoule. So I am going to represent energy released with er. Okay, that is 290 kilojoule. That is already present in kilojoule, so we don't need to convert it again. Okay, now the question is, the volume of 1 mole of gas at room temperature and pressure is 24 decimeter cube. Calculate the volume of hydrogen gas at room temperature and pressure needed for the car to travel 100 kilometer. So first of all, as we know that here we have to find the moles. So moles is equal to like the energy needed divided by energy required. So there will be 58,000 divided by 290. So when we divide it, that equal to 200, because 29 times 2 equal to 58. So 1010 cancel, so it means there will be 200. Okay, now you have to find the volume of the gas. So volume of the gas, V is equal to, the formula will be V is equal to N times 24. Okay, so here is 200 times 24, that will equal to 4,800. Okay, because 24 times 2 equal to 48 and 00 here. Okay, next question number 8. This question is about halogens, and here the properties that are given: melting point and boiling point. Okay, now we have to, what is the state of bromine at 0 degree Celsius and 100 degree Celsius? Okay, first of all, you can see that the bromine melt at -7 degree Celsius. So it means at 0 it should be at liquid state, while at 100 degrees, so it means that the boiling state is 59. So it means at 100 it should be at gaseous state. So now which one is the correct one? Gas, 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 liquid, liquid, gas, liquid, liquid. So it means here is the liquid gas. That one. Okay, now the next question, 8.2. Explain the trends in the boiling point of the halogen as shown in the table 5. So you can see here the boiling point increases as we move from top to bottom: fluorine, chlorine, bromine, iodine, astatine. Why? Because here you can write the first one, that is it increases from top to bottom. Why? Because the first one, the atomic size increase. Atomic size increase. The second case you can write, because that is 4 marks question, so you have to write as much possibility. So here the second one, that is like the molecular mass increase, atomic masses increase, and also there will be intermolecular forces increases. So I am going to write like intermolecular forces increases. Okay, so it means that when the intermolecular forces increases, so it means more energy is required or needed to overcome the intermolecular forces. More energy is required to overcome intermolecular forces. Okay. Now the next one, why is it not correct to say that the boiling point of the single bromine molecule is at 59 degrees Celsius? Because you know that the boiling point is related to intermolecular forces. Is it? Like the boiling point is related to intermolecular forces. So it means that like the intermolecular forces is present in between more than one molecule, as we already discussed. So boiling point is the bulk property. Bulk property. Okay. Now the next, iron react with the halogen in their gaseous form or a gaseous form, shows apparatus used. So you can say that the apparatus like that is will be enclosed like a glass tube. So give one reason why this experiment should be done in a fume cupboard. So the first one, because there is the use of halogen, so that halogen is very toxic. So you can write, because 1 mark question, so it means you can write only because the halogen is toxic. Okay, because the halogens is poisonous, harmful, allowed to prevent inhalation for the gas. So halogen like you can say that are enclosed in a fume cupboard. Okay, next 8.5, that is explain why the reactivity of halogen decreases going down the group. Because it's the same thing we already discussed. Because the atomic size increases, atomic size increase. Due to atomic size increase, the outer electrons that become further from the nucleus. Okay, so it means that so the nucleus has less attraction for the outer electrons. Okay, now the next one, a teacher investigated the reaction of iron with chlorine using apparatus in fig 5. Okay, that we already seen. So the word equation for the reaction iron plus chloride form iron chloride. So here are the different like the materials that are used. So now you can see here table shown. So glass tube and iron, so it means that is like collectively weight, and glass tube and iron chloride, that is collectively weight. So calculate the simplest whole number ratio, like the moles of iron ratio moles of chlorine. So it means first, for the moles of iron, as you know that mole is equal to like mass divided by molar mass. So it means we need to first identify the exact mass of iron and exact mass of chlorine. So if you for iron, I am going to write Fe. So that will be like the collectively is 56.04 minus 51.56 from here. So because when you subtract the glass tube mass, so then the iron mass will equal to 4.48. Okay, while the chlorine will equal to 56 point sorry not 56, here is 64 point 64.56 minus, iron chloride here is, and you have to subtract the glass tube mass, that is 51.56. So that will equal to how much? 8.52. Okay, now here it means that here is 4.48 grams of iron and chlorine, that is 8.52. Now for iron there will be iron is equal to Fe is equal to 4.48 divided by the mass of the molar mass is 56, so that equal to 0.08, while the chlorine that will equal to 8.52, that is the mass, divided by 35.5, so that equal to 0.24. As you know that 8 times 1 equal to 8 and 8 times 3 equal to 24, so it means the ratio is 1 iron and 3 chlorine. Okay, so it means here the equation will be iron plus chlorine, it will form iron chloride FeCl3, and here is the 3 moles and multiply by 2, because here are the 2 iron and 6 chlorine, so that again equal give us 1:3. Okay, or 1:3. So that is our equation, and that are the moles of the iron atom and moles of chlorine atom. Okay, now the next one, this question is about citric acid. So citric acid is a solid and there is information is present, so you can read this. Okay, so that reaction done in the polystyrene cup, and remember that the use of polystyrene, that is the cup that is used for exact measurement of the temperature, because that is act as an insulator. Okay, so here is the graph also shown. Fig 6 shows the student graph. You can see at 1.5, that is the reaction will be completed, and then here is the increase in the graph take place. So now the question is, shows the anomalous point at 0.60 grams of citric acid was added. This was caused by the student making an error. Like the student correctly measured the mass of citric acid, read the thermometer and plotted the point. Suggest one reason for the anomalous point. Because there are the many reasons. Because maybe it, like the student didn't stir. That is the one reason. So due to it allowed measurement, measured the temperature before and the temperature stopped falling. Okay, so that is the one reason, because there is the 1 mark question, so you just need to write only one reason. Okay, question number 9.2 is about the explain the shape of the graph in terms of energy transfer taking place. You should use idea or the data from the fig 6 in your answer. Okay, if you see in the graph, there is the decrease in the graph take place at 1.5 and then there will be increase. So it means that here you can write the temperature decreases initially. I am going to write in a short code. So that is temperature decreases initially. Okay, because energy is taken in, because you know that why the temperature decreases, because there is the endothermic process take place. And then what happened, like when 1.5 gram is added to gram is added, then what happened, then here is the hydrogen carbonate has all reacted. Okay, so it means there will be the reaction will be completed, like the all the hydrogen carbonate that will be reacted here. And then Now after like from 1.5 the citric acid is in excess form, okay, and then what happened, the temperature again increases as the energy is transferred from the room to the solution. Okay, now 9.3, a second student repeated the investigation using the metal container instead of the polystyrene cup. Like here is the use of metal container. So as you know that the metals has ability to conduct heat because these are the thermoconductors. So it means there will be like the steep line temperature. So the container, okay, sketch a line on the fixed 6 to show the second student result until 1 grams of citric acid has been added. The starting temperature of the solution was the same. Explain your answer. Okay, so here when the metal is used, so it means that there will be a steep line. Okay, let me use the exact one like this. Okay, and then there will be like you can see increase in the temperature take place. Okay, so you can write here, explain your answer. So you can write like less steep line starting from 18.6 degrees Celsius and reaching 1 gram of citric acid. Why? Because the metal, I am going to write metal is better conductor. Okay, so it means that better conductor mean it absorb more energy. Okay, from the surrounding. Now the next one, the student used a solution of citric acid to determine the concentration of the sodium hydroxide by titration. So the student has made 250 centimeter cube of solution of citric acid of concentration of 0.050 moles per decimeter. Calculate the mass of the citric acid required. So as you know that, okay, first of all the molar mass would be, because here we need to find the first molar mass, so that equal to 6 times 12 plus 8 times 1 plus 67 times 16. Okay, so that will equal to 192. Okay, now first here we need to find moles. So moles is equal to, as we know that the the concentration is equal to moles per volume. C is equal to N over V. Okay, so here we need to find moles. So moles equal to C multiplied by V. So here the concentration is 0.0500 times, and the volume should be in decimeter cube. So here 250 divided by 1000, that will equal to 0.25. Okay, so N is equal to 0.25 times 0.0500, so that equal to 0.0125. Alright, so that is our mole. Okay, now as we know that the mass is equal to moles times molar mass, we already discussed in our previous video as well, like all these formulas, all these conversions, because here mole is equal to mass divided by molar mass. So mass will equal to moles times molar mass. So here is 0.0125 times 160. So that will equal to 2.4 grams. Okay, so now the next one, this is the part of the method of the student used for the titration. Measure 25 centimeter cube of sodium hydroxide solution into conical flask using pipette, and then like here. Okay, describe how the student would complete the titration. So there are, like for example, here is the add the citric acid until there is like a permanent color change. Okay, so you can say that here is adding citric acid dropwise, adding citric acid dropwise until the color change. Okay, the first one. The second one is like swirl. Okay, the third one that you can use like repeat and calculate the mean. Repeat and calculate the mean. Okay, so here is the next question, 9.6. Give two reasons why a burette is used for the citric acid solution. Because here we can use like the two, because that can measure the variable volumes, measures variable volumes. And the second one, that is like because of the use of burette instead of cylinder, because that is more accurate than measuring cylinder, more accurate, sorry, than measuring cylinders. All right, now here is the next question. Okay, so that is our last question, that is 9.7. 13.3 centimeter cube of 0.0500 moles per decimeter cube of citric acid solution was needed to neutralize 25.0 centimeter cube of sodium hydroxide solution. The equation is below here. So now we need to calculate the concentration of sodium hydroxide solution in moles per decimeter cube. So first of all, as we know that the concentration is equal to N over V. Okay, so first of all we need to find here like the moles of citric acid. The moles of citric acid I am going to represent with N1. Okay, and then we will compare with N2. Okay, so N1 will equal to, by using the volume and concentration, so mole is equal to concentration times volume, and volume should be in decimeter cube. So you can write here 13.3 divided by 1000 times 0.0500. Okay, and then here that will equal to N1 will equal to 0.000665. Okay, now if we compare the molar ratio, there is 1 and there is 3, so it means you have to, for N2 there will be multiply by 3. Okay, so N2 will equal to 3 into 0.000665. Okay, so now here that will equal to N2 will equal to 0.000665 001995. Alright, now here, as we have to find the concentration and we already have moles, okay, so moles equal to, okay, now we need to find concentration. So concentration is equal to moles 0.001991995 divided by the volume. Okay, so for the volume there is 25 centimeter cube, so it means here is you have to like convert it into first decimeter, so here it will be 0.025. so when you divide it, so you got how much? 0.0798. Okay, so that is the answer of this question. Okay, I hope you would like the video, and thank you for watching. So keep supporting us and do subscribe our channel. Thank you so much, and here is the end of this paper. So we'll see you in the next video. Goodbye, take care.